Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So my name is Jason Van Eaton. I am the lead developer on Conference XP, have been for a couple years now. And well, frankly, I prefer sitting behind my computer and telling it what to do as opposed to getting up in front of all you guys and talking about it. So, you know, if I look like a deer in the headlights, that's because I am. So, yeah. Okay. I heard one or two laughs. That's a good start, right? So I'm going to be talking about the past, present, and future of Conference XP development during this talk. And I was really hoping to try this new approach called Beyond Bullet Points. There's a Microsoft Press book that came out last year, and this guy goes back to Plato and Hollywood and gets rid of bullet points, and you tell stories and all that cool stuff. Sounded really neat. I got about halfway through the book and ran out of time. So I decided I'd write my own book called Billions of Bullet Points. Okay? And so that's what you'll get today is billions of bullet points, and hopefully I can tell a good story or two along the way. So I've been at Microsoft for over 10 years. I started off in the games group, and some people may wonder why I ever left the games group. I mean, isn't that like ideal, getting to play games for a living? But I was interested in growing my development skills and stuff like that, and there wasn't a great deal of opportunity there. So I moved over to Microsoft Search, which is shipped in our operating system as an indexing service, shipped in SQL with their full text indexing. It's shipped in Exchange as the advanced search, and it's shipped in SharePoint Portal Server as the search engine there. So I learned a lot in that group, and then moved over to Conference XP, where I've been for the last 4 years. And I've written our current network stack, put a lot of time into supporting the various audio and video devices, and have debugged and fixed all parts of the code. So, you know, after 4 years, I kind of know Conference XP like the back of my hand. Yeah. And if you haven't ever contacted me at jasonv@microsoft.com, feel free to. I'm sure that I've probably exchanged emails with most of you or been in conferences with you online using Conference XP. So, okay, so I have 45 slides or something like that. I have about 45 minutes. I don't know if I'm going to be able to fill my time, so you guys feel free to ask questions along the way, and if I run over, then that'll be a good thing. That'll be all right. And it's helpful to ask questions in context. That way, I have a better idea of what kind of question you're asking. So, Todd wanted me to remind you guys that we do have some online training from last year's developers workshop. We brought in Developmentor to give a 2-day tutorial on C#, the .NET framework, and stuff like that. So you guys can view those videos online. As a matter of fact, you can view our developers conference videos that we did last year online as well. And I think this one's going, this 2 days, this conference is going online somewhere also. So. Okay, so I have a theme that I'm going to try to carry throughout here. So we're going to start by talking about the code of Conference XP Past, which was from the beginning to 3.0. And I have a little balsa wood airplane there, you know, kind of brittle, but functional, fun to play with. We shipped version 3.0 in December of 2004, and we've been pretty stable in our design and our networking and our core features since that point in time. The Leaning Tower of Pisa, you know, you never quite hit the mark. You never get exactly what you're looking for, but it's stable. Okay, it works. It serves its function. It gets the job done. Okay, so Todd showed you this slide. Fortunately, he didn't talk about it much. That way I get to. We have, I guess, kind of four main components here. At the very bottom is our networking layer. And that's It's good and bad. I mean, it works well. It works fine. The problem is with multicast has been kind of a deployment problem. Okay, and we'll talk about that more later. On top of that, we have our conference APIs, which are on the left. You'll see the DirectShow and Windows Media. That's for the encoding of audio and video streams. And then we have some base classes so that you can kind of write your own feature, your own plugin that'll slip into the system. Which above that is the capabilities. Those are the plugins. And then you can write custom applications. We've kind of had the same basic user interface for several years now, and a few people have decided to go ahead at the application level and do custom interfaces, but most people are at the capability level, or they just want to use the networking. So for our networking, we have a almost spec compliant, version of RTP, which is real-time transport protocol. And you can actually read the RFC online. As far as I know, this is still the latest version of the RFC. Or Colin Perkins, who is big in the RTP/audio-video world or whatever, has written a nice book through Addison Wesley. So instead of ASCII art, you actually get nice art in the book. So as far as the Conference XP implementation goes, we basically use 2 ports. We use port 5004 for all of the data, the audio, video, presentation, chat. All of the real data goes over 5004. Also our forward error correction data goes there. And on port 5005 is for the control protocol. So RTP has some extra information that you send along, says how many bytes you received and not received. You advertise yourself. You say, hey, I'm Jason. I'm joining this conference, that type of information. And the control protocol is very low overhead. It goes out like every 5 seconds. And there's an algorithm that allows it to scale to thousands of users. It increases the delay between the times that it sends it out. So it kind of has a constant, I think it's 10 kilobit or something like that, 20 kilobit overhead. Also, we use UDP. What is that? The Unigram Data Protocol or something like that. It's non-reliable. So TCP is kind of a reliable protocol. You send your data. If it doesn't make it to the endpoint, the guy sends back a NAC, which says, "Hey, I didn't get it. Can you try again?" And you keep doing that until you actually get all your packets there. Well, that doesn't work so well for audio and video. If a packet goes missing and you have this negotiation back and forth, you're going to end up with long delays. So we're UDP based, which means it's non-guaranteed, and if a packet doesn't make it or it doesn't make it in time, we just keep on going. And we also use Multicast, which I think, we'll talk about that next. So Multicast is, as Todd said, a kind of one-to-many network transmission thing. It's not a protocol, but and it's handled by the router. So what happens is you send your data out one time, and it goes out to everybody instead of you having to send the data out over and over again to all the people who are interested in receiving it. As people have said, Internet 2 is supposed to be, and mainly is, multicast enabled, and occasionally it gets turned off here and there, and then you got to ask your network gurus, that's the one in red there, to turn it back on, or just to turn it on, period. And so why would you want to use it? Oh, by the way, I should point out that bullet point in the middle there, one hop network. So businesses, schools, whatever, even inside classrooms or whatever, this is generally not a problem. It's just turned on. If you're all on the same router, then it just works. It kind of becomes broadcast at that point. Everybody who's there, it's available for them. So a picture's worth 1,000 words. If you don't use multicast, you can see the source ends up sending the data out as many times as they have people who want to receive it. This works in the retail, the pay-for market or whatever, because they gotta pay for their bandwidth. They gotta pay for the data that go across their routers and stuff like that. But in universities or in businesses, that's not necessarily the same truth. If you control your own network, you can set it up any way you want, and you don't necessarily want to bog down your network by sending the same data, multiple times across the same links. So this is the idea here is you send it out once, and then each router forwards it along just one time to everybody who needs it. So, what about data loss? Well, we started Conference XP with a focus on audio and video conferencing. And so audio and video are streaming data. There's 30 frames per second. It's always coming. Occasionally in video you'll get a keyframe, and everything in between that's just kind of the changes in the video, and then you'll get another keyframe to refresh it. And generally you will run audio and video on a wired network, which has usually very little data loss. Congestion is, about the biggest reason that you're going to have data loss. After our initial audio and video focus, we, Richard Anderson, he came up with this idea for the presentation tool. And so, we got on board with that. We have chat, and we also have a file transfer capability. Well, the problem is those aren't really streaming data. Okay, those are static data. And if you don't have all the bits and the bytes of your file, when you're doing a file transfer, then you don't really have the whole file. Okay, and likewise, the presentation in general is done in a classroom, a wireless classroom. And what we learned is that on wireless networks, data loss is common, and it generally occurs in bursts. So you don't just lose like 1 out of 1,000 packets, you lose like 5 out of 20 packets or something like that, right? So it's kind of painful. So there's a couple ways you can deal with that. Forward error correction is a mechanism where you say, look, I'm sending out X amount of data, and I'm going to send some extra data along with it, that if I lose any of those, say 10 packets, I can replace them. I can do some math and run it through an algorithm, and I can replace those lost packets with this extra data that I've sent along. So it's proactive, and it allows us to remain real time, okay? But it also increases the bandwidth. An alternative solution is to go with retransmission, kind of like the TCP approach. The packet doesn't get there, the person figures it out, and they go, oh, I need that one, and they send back and say, can you please send that to me? So it's a reactive solution. It requires NACs, which are negative acknowledgments. You say, I didn't get something, please send it again. And there's a time-bound delay to figure out that you didn't get it, then to request it again, and then for the sender to send it back to you. And that, it can work with audio and video, depending on what kind of a buffering system you have and that type of stuff. But generally speaking, it would be a much better solution for the presentation. If you didn't get an ink stroke or you didn't get the slide or something like that, it's not as time critical. Say, hey, can you please send that to me? So we actually implemented forward error correction in our code. And we do it based on frames. So a frame of data would be like one slide. A slide could be some size, say 120 kilobytes. That might translate into 150 packets or something like that. And the reason we chose frame-based, I think I cover on another slide. But anyhow, audio, pretty much it's one packet per, audio sound. You can fit video into, when it's compressed, into just a couple of packets. So there's pretty low overhead there. The way we do the calculations is it's percentage-based. So let's say you have 10 packets for a frame, and you want to do 50% coverage of that. Then we'll send 5 checksum packets to go with your 10 data packets. And as long as you get any 10 of those 15 packets, you'll be good to go. And for that case, so in the case where we generate 5, we'd use Reed-Solomon. Oh, by the way, did I mention this was going to be an egghead talk? So if you get bored and you want to go out for coffee, that's fine. If you don't understand what I'm saying, that's okay. Corner me later. Okay, so Reed-Solomon is often used in RAID controllers for hard disk storage backup. You got 5 hard drives and, okay, whatever. If the forward error correction calculation produces one checksum packet, then we use XOR to do the encoding, and that's much faster than using Reed-Solomon. And we actually turn forward error correction on for our audio and video, which generally is going to be wired, and there's not going to be data loss anyhow. But just in case there is, we have a quick solution for solving the data loss. You can turn it on per capability, so we have audio capability, video capability, presentation, chat, file transfer. They're all different capabilities. You can set them at different levels. You might use 50% in one case, 200% in another, depending on how important that particular data is, and you want to make sure it gets across. And we always round up. If if you say you want like 1% and that would yield like 0.01 packets or something like that, we'll round it up to a full packet for the error correction. Right, so how do you set the error correction? It's done in the app.config. Like I said, it's on a per capability basis. It's a handy little notation. It's some number, colon, some other number, and you're supposed to be able to figure out what that means. If you use 0 as your first number, that means it's frame-based. Okay, and the second number means percentage. So in my first bullet there, the 0:1 is a frame-based coverage of 1%. We would round up, any data packets up to 100 would just round up to one checksum packet, and we would use XOR. 0:50 means 50% frame-based coverage, and if you had more than 2 packets in your frame, you'd end up with more than one checksum packet. More than one checksum packet means we'd use Reed-Solomon. You could do something like 2:50, which means for every 2 packets you want to send, you want to do 50% coverage, which would be one checksum packet. However, due to an unfortunate implementation detail, this breaks if the frame has an odd number of packets in it. So if you have 3, we'd cover the first 2, and then we kind of break in the case of a lone packet by itself. So I don't recommend that. I just put it there to let you know, to warn you. Should put it in red. Do not do this. Okay. You could do like 100, which for every single packet you would cover it with a packet. That would be okay, but it's just as easy to use frame-based coverage. Okay. So down at the RTP layer, the main object is the RTP session object, and this manages your participants. It manages the RTP senders that you're using to send data. It manages your RTP streams, which are the ones that are going to be receiving the incoming data. You basically tell the session which endpoint you want to join, and you give it your local participant. You ask it to give you RTP senders that you can use for your various capabilities. You hook up the events that you're interested in, and the 3 events I have there, participant added, stream added, and frame received, are kind of the most interesting ones. You hook those up, and then whenever an interesting event happens, we'll notify you, and you can take the appropriate action. We are multi-threaded, which some developers haven't written multi-threaded code before, but this is what happens when things are coming in over the network and you're doing things in your UI. And so we have several threads going there. If you guys have questions, I'd be happy to talk about that, but I think it would bore most of you to tears. So, okay. So, as Todd mentioned, we are Windows-based, and because we have available to us DirectShow, which is kind of the DirectX support for audio and video devices that you plug into machines. Windows Movie Maker uses them. Windows Media Player, I don't know if you can record from that, but whatever. All of our media stuff under the covers is using DirectShow. DirectShow is been around for a number of years. It was around long before Managed Code came out, and so they're COM-based. COM is the component object model. It's a way for applications written in different languages to kind of share memory and agree on how they're going to transfer data back and forth. So fortunately, the .NET framework understands COM, and so what we did was we just wrote some managed wrappers around the DirectShow .com APIs so that we could interact with DirectShow. In the little pictures down at the bottom there, we have what are called filter graphs. A filter graph is a graph of filters. It's a clever name. And so you put various filters in. On the left, we have the a capture graph, so source. So it would either be like your camera or your microphone or something like that. And then we take that data, and generally we'll run it through a compressor. We do support uncompressed audio and video in Conference XP, which some people are starting to take advantage of. So after we run it through the compressor, then we also have filters that we wrote. And Todd said that we're all managed code. That's not exactly true. We have 10 lines of unmanaged code. So, we'll get that right next time.
I'm making a note.
Yeah, note to self. So we put our network filters into the filter graph, and as the data is coming down the pipe, then we just send it across the network. We receive it on the other side, and then we go through the opposite process of decoding it and then rendering it onto your screen or to your speakers or whatever. So for each device or for each stream that you're sending or whatever, there's going to be two graphs involved, one for the sending and one for the receiving. For all of the incoming data, there's just a graph on the receiving side. Any questions yet? No? All right.
Are you tired?
Am I tired? I'm doing well. Okay, so we use the Windows Media Video Encoder, and it's had various incarnations over the years. It started in Windows Media Player 7, 8, 9, 10. They just shipped 11 last week or something like that. So there are various media types, and the way the media types works is it kind of sets the performance / quality that you get. So how much CPU, how much memory and stuff do you have to throw at this problem, and here's the quality of video that we can output. So we actually use their lowest setting. I'm not sure if it's like lowest performance or best performance. I had a little trouble choosing a name there, but the basic idea is that we use the fewest amount of resources that we can so that we can have more streams going. So, we could choose and this is kind of what Mike Wellings is doing, is that he's kind of choosing their highest quality settings, and you got to pretty much just dedicate one machine to doing that and only that. Okay, well, we want to be able to have a machine that maybe encodes 1 or 2 video streams and is receiving 10 video streams in and decoding them at the same time. So we need to leave some CPU available for that task. There's also a benefit to the fact that currently it avoids the DirectX video acceleration. I'll talk about that a little bit later. For audio, we use the V2 codec, and the reason that we use that one is because they actually have 6 low latency settings. We tried some of the newer Windows Media audio codecs, and they didn't have any low latency settings that would actually work in our environment. So I think the RTC team is working on some nice low latency audio codecs, but until then, this is what we're sticking with. So our default is to just choose 2 of those 6 settings and do the encoding there. But again, thanks to Mike Wellings, there seems to be kind of a preference for uncompressed audio at this point in time. 1 channel 16-bit 11 kilohertz is the setting that he has recommended, and that's what we're telling people to do, and it sounds good and it works well, and everybody seems to be happy. So it does take a little more bandwidth to do that, but it's like 176 kilobits or kilobytes or something. It's pretty low. Okay, so I did talk a little bit about the fact when I showed you the architecture diagram that we have a model for plugins. It's a nice picture, by the way. Plugins, yeah. Okay, so that's yeah. Thank you. That's your opportunity to add your own features, and I'll actually talk about some of the capabilities or the plugins that we've added. And there are plenty of examples in the code that you can look at and follow if you're interested in doing your own. Okay, so that was mainly about our client and the underlying network and DirectShow and the infrastructure that we have for the client. We also have 3 services. And the first of those, and the one that almost everybody says, yeah, I was able to get the venue service to work, but then this other stuff, I was having problems with that. Well, that's because the venue service is simply a web service. Okay, it's HTTP based. Everybody can poke through port 80 to get to this type of data, and so it kind of causes the fewest problems. We have a very lightweight venue service model and concept. It really stores the icons that come up when you launch our client. So when you go out to the venue service and you say, tell me about what venues are available, it just sends back an icon and says, here's one. And it also returns multicast IP addresses for you so that you can join a multicast group and participate in a conference. And then when you go into a conference and a new participant comes in, you actually go out to the venue service and you pick up the participant's icon and the participant's information, who they are, what their email address is, and stuff like that. So again, it's pretty lightweight. It just stores a little bit of data, some icons, and whatever. And it almost always works. The Reflector Service, Todd talked about a little bit, and then most of you who have done anything with multicast are well aware of these types of bridging solutions. And the problem is that even if you're on a multicast network, that can change from underneath you. Someone can, touch the router and suddenly multicast is broken. Or there are situations where you might be on Internet 1, you don't have multicast available, and you want to be able to join a conference. So what it is basically an application layer multicast. So rather than relying on the routers to handle this for you, you set up your own machine and you let it act as the router for you. Okay. It's a nice picture, by the way. It's a bridge and it's reflected. So I get the whole bridge and reflector concept all at once. Yeah. It was cleverly chosen. Thank you. Okay. Huh? Okay. So we're still in version 1.0 of our reflector. We're pretty close to having version 2 already, and we may ask for volunteers on that. But Saleh, who was with us earlier, and his professor, Haider Rada, actually worked on this a couple of years ago, and then Saleh did his master's thesis on the idea. And we were just thankful for the code. Master's thesis, fine for him. We just wanted the code. And so the basic idea is we have 3 groups here, and over on the right-hand side you have the Internet 2 group that has a reflector on it. And a big red note here, okay? The reflector is always on a multicast-enabled group or cloud or something like that. Some people will put the reflector on the wrong side, and they'll like put it in their NAT side or something like that. And they're like, I can get to my reflector here, but nobody on the outside can get to it or whatever. Well, you got it on the wrong side. You got to get it out into the multicast group, and anybody who's not on that multicast group connects to your reflector to get into the group. Okay, that's the idea. Oh, I thought I had another picture there. Okay, well. So the idea behind the 2.0 version is a multi-reflector design. And that's where you would have one of these reflectors sitting on each of the clouds, and they would be aware of each other, and they could unicast between the reflectors, between themselves, and then you could have various groups of multicast clients. And I think this would actually be one way of solving the NAT problem, is that you could put one reflector, in your NAT group, and it could then unicast out to some other reflector on a different group. Because we do have some issues with NAT right at the moment, but I think I'll get to that in a different slide. So anyhow, yeah, that's the 1.0 design and the idea behind the 2.0 design. And our third and final service is the archive service, which, as Todd said, records the RTP streams, which means not only the audio and video, but because we do everything over RTP, it records your presentation and your chat and file transfer and whatever else. We initially had it working on SQL Server 2000. It also works on SQL Server 2005. And it's been tested to record up to 70 megabits per second And there's reason to believe that the playback could actually be better than that if multiple people, for instance, wanted to watch the same chunk of information. It would already be in SQL's cache for sending it back out and stuff like that. They wouldn't have to load it back up. And if I recall correctly, this was tested on a machine that wasn't really that special. I mean, it had a big hard drive, like 250 gigs or whatever, but it was either IDE or SATA.
It was a single hard drive, and it was a modest configuration.
Yeah.
And we don't have any reason to believe that 70 is the limit. That's just as high as we tested.
Right. As a matter of fact, Patrick Bristow, who worked on this feature, worked with the SQL team in the 2005 release to actually see if there were ways that they could help improve this scenario, and they did do some stuff along those lines. So it's probably even better in 2005.
Does it require centralized archiving? Or
Question.
Distribute the archiving?
Repeat the question.
Yeah, so the question is, does it require centralized archiving or can it be distributed archiving? Is that right? So the archiver itself is one box. It's on the Multicast group. Everybody who's in that conference, if you turn on an archive, is going in there. So I would guess it would be called centralized. Okay. Another question. Yes.
Do you support client-side recording so that I could record the class from my...
No, we don't have... so yeah, the question was, do we have client-side recording? And the answer is no. You don't record just to your local hard drive or something like that. That's actually one of...
Yeah, you can install Archive Server on your local machine.
Yeah,
and that will work. I've done that.
True.
So
Okay.
can you repeat that?
Yeah, so Todd says you can install Archive Service on your local machine. That requires getting SQL on there, and getting it configured and stuff like that. The other solution, of course, is Fred Vidion's solution, where after the fact he takes the archive data and he transcodes it back into a WMV file, and students can then grab that file and put it on their local machine and just watch it in their Windows Media Player or whatever. So it's not a real-time storage of it. Okay, so I told you I had a theme going throughout my slides here. Here's my second theme slide. We did code of CXP past. This code of CXP present. Don't jump ahead of me, okay? All right. So this is between 3.0 and 4.0, which is our current release. You can see we've now gone from the balsa wood airplane to the jumbo jet there. Yeah? Okay. Good. So in 3.1, we added quite a few new capabilities. We added a Windows Media File playback, and so Todd showed a video earlier. We can broadcast that same video from inside Conference XP. I guess the one main issue that people have when they can't get it to work is that they've done a variable bitrate encoding on their video. If you just get Windows Media Encoder and do it as a constant bitrate encoding, then everything should work out just fine. And we don't add any extra compression on top of that, so encode it at whatever compression rate you want, and that's how it'll get sent across the network.
Jason,
Sir?
how difficult would it be to be able to incorporate variable bitrate files into
Don't know. But I know that you helped me find the question was, how difficult would it be to use variable bitrate encoded videos? I don't know. I just know the constant bitrate works. And actually, Nathan helped me discover this problem when I was down in New Zealand last year. He's like, yeah, I have this video that just doesn't work. And so we figured it out. So that was great. But I don't know. It's actually pretty trivial to get Windows Media Encoder and do the transcode, but there's always things to fix. Maybe you want to sign up for the variable bitrate encoding. Ivan.
Have you had anyone besides the really high-end archiving people suggest recording uncompressed and then compressing depending on what the client capability is so that you retain sort of the highest quality archive?
Are you talking about for the Windows Media File playback?
In general, sort of, I mean, the general theory
Or-
being you always record sort of and just keep the highest quality source. And then you can dumb that down if you're on a laptop, handheld,
Okay.
slow network.
So the question was about sending uncompressed data as the source and then compressing things later. So there is the option to turn off compression in Conference XP if you wanted to send uncompressed audio or video data. And as far as for a Windows media file, they probably have, or they might support some kind of uncompressed version also. But that's, bandwidth intensive. Sure. Okay. And the second thing that we added in 3.1 was a screen scraper desktop capture support. And that ends up being kind of very cool. It's kind of like the catch-all capability. If you don't have a specific capability to do something, if you don't have like a Word Word capability or an Excel capability or whatever, so that you end up with the same data on both sides, you can at least see anything that's going on somebody else's screen. They just say, here, let me show you what I'm looking at. So that was pretty cool. Well, I'll dive a little bit into these bottom 2 bullet points. They're really only for eggheads like myself. But so COM has single-threaded apartments and multi-threaded apartments. And so it turns out, basically, I'll cut to the chase here. We have multiple threads going on in our system. Okay, you have your user interface thread where you're pushing information down. You have your network thread that's pushing information up and stuff like that. It turns out that COM doesn't like it when you touch objects from various threads. Okay, the thread that you create an object on is the thread that you always need to touch the object from, and then everything works fine. For a single-threaded apartment, which is what DirectShow does. So I had some fun nights, debugging really cryptic, weird errors where things would just break, and I'd be like, "Wow, how did that happen?" So anyhow, just note to the developers out there, if you do anything with the audio and video stuff, that you want to always do it from the same thread. Okay, pick a thread, do it from there. The other thing that I did in 3.1 was included the 7 megabytes or whatever of DirectShow headers and source files that we actually need, saving everybody a 250 megabyte download of all the stuff you don't need. So that was kind of cool. And then in 3.2, which was for our developers conference last year, I added one new capability, which was the shared browser capability. And it was kind of going to be cool, but actually the desktop capture is cooler because you can do any application in there. The shared browser idea, of course, is that we can go visit websites together and stuff. But there's so many websites today that you have to log into, and the security and all that kind of stuff that kind of breaks in a lot of cases. I also added quite a few samples into the code base. Just very simple samples like RTP chat. Here's how you create an RTP session, get a couple people connected, and send text data back and forth. And then I did rich text, just a simple whiteboard. So our presentation tool started off as this, really simple example of, how to do a whiteboard and maybe send a slide, and 8,000 lines of code later, we kind of got it working. So, I wrote like the 100-line whiteboard capability. Here's how you send ink across the network. Okay. Right. So, and then I have very simple samples for how to use the managed DirectShow components, and then also how to add in the network filters and get the video to go across the network. So, if you're looking to understand that stuff, those samples really cut to the chase of how to get that type of stuff done. How am I doing on time?
You're good. It's 11:15.
Okay, thanks. Right, bug fixes. By the way, billions of bullet points. Just keep that in mind. Working on it here. So we've had a recurring problem. It started in our client, and we kind of fixed it up there, and then now it's occurred in the Reflector too. The .NET framework defaults their sockets to 8K buffers, and we send enough data that an 8K buffer isn't long enough, and so we fill it up, and once we fill it up, then data starts getting dropped, and it goes missing. And so pretty much anywhere that we have our sockets, we've had to go fix them up to allow like 80K, and then we haven't seen any packet loss. So we had to fix that up in the Reflector. Added some support for controlling the video keyframe rate. in the app.config file. It defaults to 8 seconds. So in previous incarnations of Conference XP, you would come in, to a conference, and it could be up to like 8 seconds before you saw somebody's video, because you would have to wait for a keyframe of video to come through before it would actually initialize properly. So we have now made that configurable. Well, we did in 3.2, and it's even better. DirectX video acceleration. I told you I'd get back to this one. This is one of those story things. This is another one of those things where you turn Conference XP on and suddenly your machine reboots. And you're like, what? And you try it again and you get a nice big blue screen, and then you try it again and you get a couple of video windows and they all freeze. You're like, wow, that's cool. So DirectX video acceleration is this feature on modern graphics cards where they actually now have good GPU graphics processors in there, okay? 500 megahertz, 600 megahertz, that type of thing. And so the basic idea is they want to unload some of the encoding and decoding and stuff onto the video card. Unfortunately, I guess we used DirectShow in a different way than they were anticipating. And so if DirectX video acceleration is enabled, all kinds of weird things can happen. And so I told you that we chose the Windows Media version 1 media type. Part of that was for the better performance, right, the lower performance. And the other is that it avoids this DirectX video acceleration problem. So we did try moving up to version 3, basically, of their media types for encoding. And not only did it double our processor utilization and stuff like that, but all these really weird bugs started happening. And we were able to live that way for a while because we didn't have the latest graphics drivers. So as people were slowly upgrading their graphics drivers, this problem suddenly became bigger and bigger and bigger, and so I had to, figure out what was going on there. But yeah, the things you learn. We also improved our Reed-Solomon performance, lower overhead, faster, and we increased the number of packets per frame. So we had a limit of 750 or something like that, and now we're up to 4,000. If for some reason you need 4,000 checksum packets, you can have them, but that's a lot for one frame, just one. Oh yes, 3.5. Okay, so I've actually redone our audio-video support twice.
Did you get it right this time?
Pretty much. It's more right. Yes. So the first time, Conference XP, 1.0 or whatever, we supported about one device. Like Todd said, it was the Sony DFW VL500s. We've got 6 of them still sitting in my office because that's what we used. That's what worked. In the next version, and so if any of you use Conference XP 2.0 or up until about 3.5, we had this idea. There were 3 video settings you could choose. And what we were really trying to control was the bandwidth. Okay, you could have 1 megabit, 500 kilobit, and 250 kilobit, something like that. Well, behind the scenes, that wasn't the only thing we were trying to control. That's all we should have been controlling. But we were also saying, we want you to use RGB 24-bit, and whatever. Well, not all cameras support RGB 24-bit color. Okay, there's various encodings that, like the webcams and stuff like that do. So here's what we did in 3.5. Oh, and the other thing is we only supported the WDM, Windows Driver Model drivers, which, by the way, that's the latest and greatest technology for the last 5+ years. And there are VFW drivers, which is video for Windows, which is really old technology, but there's still a lot of those floating around. So in 3.5, it was time to finally get it all right. Okay, so what we did was we quit forcing the video devices to our desired settings, and basically we let them tell us what they're capable of doing. Okay, the other thing is that rather than taking these bazillion devices and forcing them all into our UI and saying, here's the things that we'll let you control, all of them actually support their own user interface. So we actually just bring up their user interface, and they know what they're capable of supporting. We let you tell them what you want to do with their device, and then we just ask them when you get done, well, what did the user do, and how can we, automatically compress that and stuff. This had the added benefit of not only allowing us to support WDM, but to support VFW. Because basically, no matter which driver type you're using, they both support this idea of here we'll show our own interface for how to control us. And in the user interface, well, so not only did we set the default keyframe rate for video to 2 seconds, but we also allow you to do a slider and put it wherever you want, 1 second, 8 seconds, which is the normal default or whatever. The interesting thing we found about this is that you would think that if they were sending a keyframe rate like every 2 seconds instead of every 8 seconds, which is their default, there would be some kind of performance penalty, whether it be increased network utilization or increased CPU or something. But despite all our testing, none of us could figure out what was changing. The network utilization remained at the fixed limit that we had set it at. The CPU utilization didn't change or whatever. So it seems to be one of those we got this for free type of things. I don't know. If you've written any code, nothing's for free, but we couldn't figure out what changed. So this is good. So now when you come into a conference, and things are already going on and whatever, it'll be 2 seconds before you get to see somebody's video instead of 8 seconds. Okay. Right. The other thing that we did in previous versions, like I said, we had these 3 settings. Okay, you could do 1 megabit, 500 kilobit, or 250 kilobit. Well, now we have a slider. Okay, you can pretty much set your compression wherever you like. And I don't guarantee that the compression on the high ends actually gets that far. You may not even be generating that much data. So really compressing higher than the amount of data you're generating doesn't work. And I had trouble figuring out what the actual max for the compressor was that I could put the max correctly. So I allow you to go up to 5 megabits in our user interface, and the compressor will just max out wherever the compressor maxes out. But most people aren't interested in really going up the scale too much. Most people are interested in going down the scale, and that does work. You can take it down. I think maybe I limited it to 50 kilobit or something on the low end. So, right. And so in previous versions for audio, you had to go into the system settings and you had to set your defaults to be what you wanted for your input and your output devices or whatever. We finally added a user interface component so that you could choose your audio input source, you could choose your audio output source. They can be the same. They don't have to be the same. They can be whatever's available on your system. And we also have this idea of autoplay. You go into a venue and remote participants' audio and video will generally start auto-playing. You can configure that in the UI. Well, previously we had one checkbox to control both of them. But for things like an audio bridge, you don't want necessarily everybody's video to be playing when all you're interested in doing is routing the audio from one group over to another. So we separated that out, and you can turn them on individually. Sir?
Quick question on the audio input. Is there any way at the moment to grab the audio from the DV string?
The question is, can you grab the audio from a DV stream? I think if you will give me 2 more slides, you'll see that the answer is no. Yeah, that's a problem. It's been a personal annoyance of mine because I don't like it when things don't work. But so the one problem that we have with audio and video devices is when they're combined, like in a Handycam or something like that, and it all comes down an S-video pipe. The way our system is architected, I showed you we have different filter graphs for sending and receiving. So not only do we have them different for sending and receiving, but audio is one graph for sending, video is a graph for sending, presentation, does its own sending, not in a graph. So I need a way for those to be in the same graph because they're coming down the same pipe, basically, and then I need to split it into different senders there. So, it's working up here.
It's
Sir?
been a while since I've used it, but doesn't the OrangeWare driver set pull that audio out of that FireWire stream?
It's possible.
I think it demuxes the audio. I think it makes the camera appear as a separate audio and video source.
Okay.
It's for OrangeWare Incorporated. Do you remember what the company? If you do a search.
Yeah, it's OrangeWare.
That's why we need
It's like-
experts.
It's $25 or something.
It's the DV cam driver?
Yeah.
Yeah, I'm pretty sure that is the case.
Yeah, so it makes,
Okay.
it demuxes the audio and
Okay.
makes it look like it's like.
Like a device.
Yeah, it's two separate devices.
Yeah.
Okay. So yeah, so we are kind of a device-focused system, and so when they're coming down two pipes, when it's kind of one device doing two things, that kind of messes with the way we've been architected. But according to Mike Willings, if Orangeware or someone has drivers that make it look like two separate devices, then we're good to go. Yes, Ivan.
Are you generating the filter graph on the fly
Are we generating the filter graph?
for audio send, video send,
Yes.
audio receive?
So the
video
question is
receive?
if we generate our filter graphs on the fly. The answer is yes. You choose which devices you want to use. By the way, we do support multiple video devices, so if you want to send 3 or 4 video streams, that's great. Encoding is like 2 to 3 times as expensive as decoding. So the more video streams that you choose to encode means the less CPU you have available to decode incoming streams. But if you have just a dedicated machine for sending and who's not actually doing interpreting of incoming data, then you can do more streams that way. Well, we got the questions flying now. This is good.
Have you
Fred.
thought at all about multiple audio streams?
Yeah,
If
has
you-
anybody asked you for that, Jason?
Yeah, it's in here somewhere.
Multiple audio streams?
Yeah. So we when we did the work to separate out the audio input and output, I mean, one of the questions that we asked was, well, do we want to just really parallel the way we're doing video and allow multiple audio inputs? And the decision that was made at that point was, it's trivial. The code that we now do for our audio, I mean, you could just basically copy the loop over and populate a box to do that. The problem is how to map things in the user interface. Okay, so we have one video stream that gets the audio attached to it, and all the other video streams don't. If you had multiple audio streams, you'd need a way to say, I want this audio to go with that picture and whatever, so that people can control it. And we didn't want to add the UI goo to get that done. So there's no technological reason that you couldn't have multiple audio input streams. It's just a question of how to present it in the user interface. Okay. There's one, yes, in the corner there. Mm-hmm.
Just wanted to know if you are using multiple cameras, if you do full uncompressed DV, does that incur any sort of massive functionality? Because you're not really doing any encoding.
I'm sorry, I didn't hear the full question.
If you just send full uncompressed DV, and if you turn compression off,
Mm-hmm.
does that save you any CPU cycles?
Okay, good question. So the question is, if you send uncompressed video of some kind, does that actually save CPU? There's potential for that. I think what we found is that with uncompressed video, that it's probably our network stack or the fact that we're built on top of the .NET framework. There's a couple layers here that starts to get in the way and slows things down, and you end up getting some lag. So yes, the CPU utilization wouldn't be there for the compression aspect of it, but the network churning can also build up your CPU utilization, not to mention it's really hard on your bandwidth. Now, if you have big bandwidth, that's cool. Most people are kind of in an in-between stage where they've got good bandwidth but not great. So yeah, there's an opportunity, I think, for improvements there in .NET 2.0. They were planning on redoing some of the socket stuff so that you could actually get some better throughput. And rather than having to, kind of chunk the data up yourself, you could have pointers into your data, and they could just send those types of chunks. So I think there are ways to, to get around that, but it's a trade-off at this point in time. It's a good question.
But have we done any actual measurements of uncompressed video CPU utilization?
Well, I'm sure that I did last summer. I don't know if I have it in a document somewhere, but the problem was the lag, and with the lag it kind of became unusable. Okay, where was I? Yes, sir.
I don't know, I just want to make a comment about the uncompressed video thing. I think it's virtually impossible given the state of the bandwidth right now. I mean, we're talking about 1 gigabit to 2 gigabit per second. bandwidth needs if you don't compress the video. That doesn't even assume that that's quality, so it's potentially a physical impossibility.
Okay.
Unless you do 1 frame per hour or something.
So Hyder was saying that he thinks that sending uncompressed video is probably a physical impossibility for most networks. What, 1 to 2 gigabits or something like that. I think we have some guys in here though that are working on doing some uncompressed type stuff.
Well, when you talk about uncompressed video, you have to say what resolution.
Okay.
You're dealing with. So the only video I mean to get up to 1 or 2 gigabits a second, that's uncompressed HD data rates, but NTSCs at reasonable sampling rates is only 95 to 135 megabits. So
Okay.
that's at NTSC resolution. So I think I'm not sure what resolution you're talking about at a gigabit or 2.
Well, I'm going along the vision that you mentioned that we're going to have an HD experience in
Right.
direction.
Yeah. So there are multiple ways to compress that or to send it
If you
up.
go with the NTSC and you have multiple streams, pretty quickly you're going to get to the 1 gig.
Yeah.
Right.
That, 4 NTSC could be 1 HD.
Mm-hmm. Right. So if you have multiple of these HD streams, then yeah, you're gonna chew up the bandwidth. Okay. Any other questions? Moving on. Okay. And then in 3.5, we also had some reflector bug fixes. We had this guy down in Australia who kept getting abnormally disconnected from our reflector, and we didn't have any mechanism to handle that. And so we kept forwarding all the data that we were receiving to him, and then his network got shut down a couple times because he had a bandwidth limit. He's like, would you guys please fix this? I'm like, well, why are you getting disconnected abnormally? But anyhow, we fixed it. And then we also support multi-NIC in our reflector. Where you could have one NIC as your unicast send and receive, and the other NIC is your multicast send and receive, and then we bridge the data across the two. So we had a little bug in there, got that fixed. This was actually thanks to a different guy down in Australia, the guy who did the School of the Air, and Todd had that big complicated satellite network and stuff set up. He found the bug, fixed the bug, and then let us know what the fix was. So that was pretty cool.
Is it much performance on multi-netting? Having two network cards in the...
So the question is there much of a performance gain? Well, there can be performance gains, obviously, depending on the if they're gigabit cards or whatever on each side. I think usually the reason that this is used more normally is that you need to bridge a unicast side and a multicast side, and they're on separate networks, and so you use this one box to do the bridging between them. All right, 4.0. So the main emphasis in 4.0 was to roll forward to Visual Studio 2005 and .NET Framework 2.0. It was a little more challenging than it should have been, I guess. What are we going on? 7 months now, 8 months, something like that. Okay. So there's some minor things that I've learned along the way. Most of these are egghead type bullet points. So in Visual C++ 8.0, they have a dependency for distributing their runtime now. And basically it forces it so that you have an everyone install. So you guys may have noticed in 4.0 that we no longer allow you to install just me. It's for everyone. That's the way I always installed it anyhow. But they also have changed the managed C++ syntax. So we moved forward to the new syntax. And then there were various portions of the .NET framework that were obsoleted. And so they give you a little warning message in the build, says, don't use this anymore, please use this. This is a new way to do it. And we always shoot to have a 100% complete, clean build, no errors, no warnings. So we went through and fixed all the warnings, which is pretty much what most of the rest of these are. So the configuration settings changed. As a matter of fact, they're pretty cool now. It used to be that the configuration settings were this read-only thing, where you could put stuff in the file and you could read it in and that was it. Now settings are read and write in the .NET framework, so that's pretty cool. So rather than storing things in the registry, they're suggesting that you now store them in config files. And you can do it application level, or you can do it user level. So each user can have their own settings in the config file, and the .NET Framework just kind of handles that for you. So very cool. Some of the DNS calls changed, like to resolving host names and stuff like that. We had a custom rolled ACL support that ultimately made it into the .NET Framework, so we moved over to using the latest and greatest. We use that on our venue service data file. I don't know how we ended up with white space at the end of some of our IP addresses, but we had this situation, and it was fine in 1.0 and 1.1, and 2.0 suddenly quit parsing those IP addresses instead of just trimming them and then parsing them on their end, which they must have been doing before because white space was okay. They started failing, so we had to go find the places where we had allowed that to happen and stopped it. And then they added some XML serializers, which is basically for each of your classes, they kind of do this XML layout of the class so that they can send the data across the network. And that used to be done at runtime, and apparently that was one of the slow startup costs and stuff. So what they did is they moved that out to a kind of post-compile process, and they turned it into a DLL or a picture that they can look at and go, okay, we know how to serialize this. Then there were a couple major updates. The worst part of this whole roll to 4.0 is that our RTP filters quit working, and when those quit working, then audio and video doesn't work. And when audio and video doesn't work, we don't have much to show for it. So anyhow, the way that worked is we were trying to be all managed code. Unfortunately, the DirectShow code behind the scenes has, I'm sorry, did I say managed? Okay, we're trying to be all managed. Behind the scenes, DirectShow has some unmanaged code. And if you initialize the managed side first, there are some unmanaged cases that can be initialized, and then there are some that can't. And we ended up in one of those situations where it couldn't be. So our 10 lines of unmanaged code is to work around this problem where we go in on the native side or the unmanaged side, and we do our initialization there, and then we come over to the managed side and get things up and running. IPv6 addresses. This was unbelievable. So in 1.1, you couldn't parse an IPv6 address unless the protocol was installed on the machine. And if the protocol wasn't installed on the machine, an error was raised. So we had to catch the exception. We had to go, oh, this is we're trying to parse an IPv6 address, and IPv6 isn't on the machine. That was the way we knew that it wasn't on the machine. We'd get this exception. Well, now they can parse IP addresses without IPv6 being on the machine. So everywhere we were expecting an error to be raised, an error was no longer raised. So we ended up in, weird situations where IPv6 wasn't on the machine, and they could parse the address and stuff like that. So that was kind of painful. So we have various, networking places where we are interested in IPv6 on our services and on our client and stuff like that. So I had to track down all the places and fix that up. Okay, Todd did mention that we've had support for multiple venue services in our UI, so you can go into your drop-down box and we can precede them for you, and you can see the list that we have, and you go choose one you want, or you can add your own. I now made it so that the reflectors and the archivers, you can have multiple preceded versions of those also, and I think we have about 5 or 6 of each of those in our latest client. And as Todd said, if you guys get venue servers, archive servers, and reflectors or whatever set up, and they're available for public use, and you want to let us know about them, we can add them into the config file and make that available on the website for people to update their lists. Thanks to Gino Sorcinelli there in the back. We made sure that we were compatible with PowerPoint 2007 and OneNote 2007. There were a couple of minor issues there, but we got those resolved. Once again, in 4.0, I updated the DirectShow headers to be the latest and greatest. Some of you might be aware of the student client. We used to have a whole separate install for the student stuff, and it basically turned off the audio and video support, and it was just kind of a classroom support thing. There wasn't really that much need for it to be a whole separate install, because really the only thing that changed were like 3 or 4 lines in the config file. So I just added an extra config file. If you want to just take the student config file and make it the default one, you can, or you can just kind of copy the settings out of it or whatever. So, and we have done some Sir?
Can you just spend a minute or two more on what you talked about in terms of student client config?
A minute or two more on it?
A little bit more.
Maybe 30 seconds.
30 seconds?
So the idea is in the config file you can turn student mode on or off, and you can also kind of choose a default venue that you want to join. And what happens is when the students launch Conference XP, they kind of bypass all the audio and video stuff. They go directly into the venue that they're supposed to be in. So it's kind of like the one-touch, user experience. You go where you're supposed to be, and we've done our best to make it so that they can't stir up too much trouble.
Quick question about that too. Is it possible for a student, you've disabled them from loading capabilities as well in student mode, right?
Yeah, I think so. So the question was if we had disabled them from launching capabilities in student mode, and I believe that's the case. There was something else I wanted to say. Oh, yeah, generally speaking, the way Gino's been doing this, and he'll probably talk more about it, is that the students are receiving the PowerPoint presentations into OneNote, and the beauty of that system is that they can then take it with them. So it's a storage for the presentation stuff. They can also add their own notes on top of it, and that doesn't get sent back out to the class. So OneNote's kind of a one-way in, no way out type of thing. So that works really well. It's automatically saved. They get the professor's data in, the professor's ink and stuff. They can add their own ink, get saved locally, and so on.
I just want to reinforce the point that you're making there. The opportunity, at least in our class, for the students to save that stuff on a flash and thumb drive and then walk out with everything that you were talking about and everything that they need. It's a pretty, I think, a pretty dramatic dynamic improvement over what we were doing before with standard classroom presentations.
Okay.
Very nice.
Thanks, Gino.
Does it also work with your screen scraper? I mean, like if you're browsing the web and stuff like that?
No, Screen Scraper is streaming data. So we actually take bitmaps of the desktop, encode it down, send it across. So that would be something that would go into an archiver.
They can take a screenshot.
Yeah, actually, so presentation does have a screenshot capability where you can. So you have to manually, push the button to take the screenshot. It's not a streaming type of thing. So all the real audio and video streaming and the screen streamer and the Windows Media File, those would all go into archive and they could be transcoded into a Windows Media File. The presentation. You can insert a screenshot in a presentation, and that would go into OneNote, but it's a manual process.
Have you considered extending the archiver to take things like screenshots instead of being purely RTP?
So the question is, can the archiver, have we set it up to take something like screenshots? The answer is it does, as RTP data. Everything that goes into the archiver is RTP data, and everything that comes out is RTP data. So we don't store them as their own file types, as JPEGs or whatever. They don't go in like that. Everything goes in as RTP data, and everything comes out as RTP data. Uh-oh, I see smoke coming out of his ears. Okay, let's move on, because there is somebody who's going to get up and talk after me real fast before lunch. Did a few bug fixes. There's one audio device that Mike Wellings pointed out that didn't work in the 3.5 release. That was really a bummer. Didn't find out until like the day after we released. So anyhow, fix that. Bullet Point 2 Visual Studio has added some cool stuff for developers, in the Visual Studio 2005 release. One of them is called the Manage Debugging Assistance. You can go into your debug menu and turn those on. And if you have interop with native code and stuff like that, it'll help you find problems in your interop. One of the other things they added by default is checking for cross-threaded UI calls. So you have multiple threads. One of them is your GUI thread, your graphical user interface thread, your main thread, the one that has the message pump on it. And if you try to touch some of your UI components from your non-GUI thread, then Visual Studio will throw an exception that says you're doing a cross-threaded UI call and you need to get that fixed. This only happens when you run under a debugger. At runtime, they will let whatever happens happen. Sometimes UI calls work. Sometimes UI calls don't work. if you're on the wrong thread, okay? But if you're running under a debugger, then they'll stop execution and let you know that you got a problem. So we fixed a few of those. Fixed some bugs changing between venue services. We weren't really properly connecting to a new venue service. You know, if you hadn't been there before, you should get a dialog that asks you to fill in your user information, but we were not following that whole process. We fixed those up. We had some performance issues where we were connecting to the... who doesn't? Okay, but with the venue service, we were connecting to it and contacting it multiple times when we really only needed to do that once. So... yeah, we had some hard-coded stuff in our installers that wasn't done quite right. And we also have a feature where if you write your own capability, all you have to do is drop it into the folder where Conference XP is installed, and the next time you launch Conference XP, we'll find your plugin and we'll list it in our list of available features. That was the single worst chunk of code in the code base, so I took the opportunity to rewrite that this time around and simplified it dramatically and increased the functionality. Yeah, that's a good result. Okay, here we go. Here's my theme. Okay, it's the final theme slide here. Code of CXP yet to come. Okay, we are coming up on Christmas, right? So what's coming after 4.0? As Todd already said, we have plans to move our strings into resource file for localization purposes, Japanese and Chinese. And Daniel, who's going to get up after me here down in Brazil, I think he's already localized most of it into Portuguese anyhow. So maybe we'll be able to leverage that work as well. We're looking to create a software audio bridge for conferencing using Windows telephony API. So we want to be able to bridge the phone guys with the CXP internet guys and get that working. Codeplex and improve Vista compatibility. So I got quite a few slides on feature ideas here. Some of these aren't that new if you've attended conferences or seen my decks before. They're things that we would like to accomplish, but not there yet. One of the biggest ones would be to separate the streams onto separate ports. So instead of having your audio, your video, your presentation, your chat, and everything else going down 5004, your forward error correction, and all that stuff going down the same pipe, if you separate that out onto separate ports, people can subscribe to whatever data they're interested in receiving. So you can choose to get your audio and not the video, and your network doesn't get flooded with all the video data anyhow. Now you can currently choose not to play the video, but you're still receiving the video data whether you want it or not. Okay, and that's problematic on wireless networks and stuff like that. So that would be really cool. Maybe the session initiation protocol for getting things started. People say they want security. That's problematic, I got to tell you. Figuring out how to do your authentication and your what's the other one? That's one. Authentication, authorization, securing your data on the network by putting a crypto something over it. Wow, that's big work. Most people probably don't need it. But the best we have to offer right at the moment is we have a gentleman's agreement on our venues. You can, if you've ever set up a venue service, you have the option to put a regular expression in for whether or not you want someone to see a venue, and if their email address matches that regular expression, they can see it, and if it doesn't match it, they can't. I think it's functional enough. All right, moving on. Retransmission is something that we funded as an RFP last year. We have the code. It needs to just be reviewed and incorporated into the code base, or maybe sent back for a few more changes or something like that. But and that might be a 4.1 item there.
Who submitted that?
Yeah, Wenjin from Missouri, I think. Yeah, I was miss something. Missouri. So somebody's asking about multiple audio sources. That's certainly a possibility. It's about getting the UI to match up with the video, or maybe, my idea was to just put all the audio in one list, and then you could mute everybody at once, or you could, very quickly go through the mute, instead of having to go between all your video windows to mute audios. So there's various ways of approaching it. I was overruled on that. Codeplex.
Can you elaborate on that, or is your tongue tied around that?
No, I okay, fine. facetious. Better support for DV camcorders. I would like to understand the issue, but if we have a workaround, then that's great. Ink on video might be interesting. If you had a back channel to, you draw on your screen of what you're seeing, and it, you send it back to everybody, and hey, what's that object in the background type of thing. Windows has some native support for acoustic echo cancellation. We'd like to, see if we can turn that on. And video quality switching in a venue. Would be nice. Right now our solution is you have to go out of the venue, go change your settings, go back into the venue. It'd be kind of nice if we could just do it all in the venue. So everything goes into Archiver and comes out as RTP, but the presentation, that type of stuff, the APIs, according to Patrick, aren't what he would like them to be for that. We have this, there's 2 GB limit in SQL, and we handle it one way. There's probably a better way to handle it, but it's functional, what we do now. And we have a slow playback because we calculate some statistics on whatever you recorded when you're playing it back. We got to do the calculations once when you are recording it and store that information instead of having to recalculate it every time that you play back. Yeah, okay. We have a lightweight venue concept, maybe we should do something different, a la Access Grid, where they, store all their data or whatever. Instant venues, where you could just, say, hey, let's go have a meeting right now, and we'll create our own venue on the fly, and that'll just work. Maybe some kind of scheduling mechanism where you want to send out an invite to everybody, and then they could all, join at the same time, type of thing. Multi-reflector code, we have it. It needs to be tested, debugged, and have some UI stuff added to it. And like I was saying, I think it would solve some of the NAT problems if you had a reflector on the inside of your network and one on the outside. You could bridge them. And we'd be happy to take volunteers for anybody who wanted to, look that code over and debug it and test it and stuff. If you're set up at your school for that type of work, that would be cool. And then Todd added this slide for me, so thank you, Todd. He would like to see something for multicast detection / failover that's a little better than what we have now. We do have a partly functional solution that tells you whether or not you're multicast enabled and or whether or not you're on Internet 2, and those aren't necessarily the same thing because you can be multicast enabled without being on Internet 2. But he'd like to see some of these things where if we determine that you're not multicast connected, we fail you over to a reflector, and it's kind of transparent and you don't have to choose it and stuff like that. And then there's always your guys' ideas, and I think we'll have some sessions coming up where we get to discuss those types of things. And now they're coming for me. That's right. Thank you, Ivan. Okay, any final questions? And if not, we'll get Daniel up
here.
So
we have 5 minutes before lunch. Why don't we bring Daniel up right after lunch?
After lunch? That's fine. That's fine.
Okay.
Good.
Any questions?
All right. I can't believe I filled my time.
I have just a quick question on the Reflector Service NAT problem.
Mm-hmm.
I seem to remember, I'm not sure if you guys have tried this, I seem to remember that I used a VPN like Hamachi, and it worked through a NAT. But I'm not sure if it would work in all circumstances.
Okay. I don't personally know, but
there are some free solutions out there that you can download and experiment with, like Hamachi and lots of other ones.
Between
I think it worked.
Between like this and the OrangeWare drivers and stuff like that, that's why we need to build a community. I mean, everybody has different, expertise in different areas, and I'm kind of a jack of all trades, master of none, type of thing. So this is good information.
It works for the venue service as well if you want to secure it, because it gives a fake fixed IP address that it doesn't matter if you are on a dynamic assigned IP address or fixed, you always get the same for each machine, and it's apparently totally secure, so it's one workaround for that.
Okay, thank you. Yes, Nathan?
The screen streamer service, I've sort of looked at it and not in too much detail, but I was thinking, is there any way to be able to increase the quality of that?
Okay.
I think looking at it briefly, I remember it's really...
Yeah, so the question is about the screen streamer. It's another one of those personal things that, always sits in the back of my mind. Right now, the way a screen streamer works is we send out 1 frame per second And over time, the quality can kind of degrade, and then suddenly it'll, it's kind of like it gets a keyframe again, and it kind of clears back up and whatever. For a lot of applications, it works pretty well. If you have black and white text, not complicated desktop backgrounds and stuff like that, it works better. I was never able to figure out how to properly control the bit rate for the encoding, or how to control the frames per second properly. And when, like I'm capturing 1600 by 1200 on my monitor, that's a lot of data to shrink down. So I got something that's moderately functional. So yeah, it annoys me that I don't have full control of it. I prefer full control, but other questions? Good. Okay, well, I guess it's lunchtime. I saw them setting up over there. Do you want to announce, or we're just...
First off, thank you.